Hi students and friends, welcome to the channel Learn and Teach by Ayaz. So in this video lesson, I'm going to continue my CAIE 5070 past papers, and this time I have selected May-June 2022 and the variant is 12. I'm not going to read the instructions for this video as you all know the instructions. So straight away, let's start the paper. Number one, a student investigates the rate of reaction between calcium carbonate and hydrochloric acid. This is a conical flask and it's attached with a delivery tube, and there's a gas syringe in order to collect the gas. We have calcium carbonate solids in the conical flask and hydrochloric acid. The volume of gas in the syringe is recorded after 1 minute. The experiment is repeated using different concentrations of hydrochloric acid. Which additional pieces of apparatus are essential for the investigation? Balance, yes, we need balance because there will be a change in mass as gas is produced. Number two, measuring cylinder, yes, we need measuring cylinder in order to transfer the acid. Three, stop clock. In order to find the rate, we need stop clock to note down the or measure the change in mass or volume after certain time. So all these three choices are correct. So D will be the right answer for this question. Number two, which statement is correct? A mixture of liquids with boiling points which differ by 35 degrees centigrade can be separated by distillation. This is correct statement. You can separate the liquids with boiling point difference of this. They can be separated by distillation. B, locating agents are needed to identify the colors present in ink. In order to check the colors present in the ink, we need chromatography, but locating agent is not needed. Locating agent is needed only for colorless substances. Needed for colorless substances in the mixture. So this is wrong. C, the desalination of seawater to produce pure water is achieved by fractional distillation. It is achieved by simple distillation, not fractional distillation. Simple distillation. So this is also incorrect. The last one, RF value of a dye in a chromatogram can be calculated using the formula RF distance moved by solvent divided by distance moved by spot. This is wrong because the equation is distance moved by the spot divided by distance moved by the solvent. So this is also wrong. Only choice A will be the right answer in this case. Number three. Some reactions of an aqueous solution of compound X are given. When a few drops of aqueous sodium hydroxide are added, a white precipitate is formed. No extra information is provided. So we may have these three ions present in the aqueous solution: Al plus 3, Zn plus 2, and Ca plus 2. Statement number 2, when dilute nitric acid is added and the mixture is formed, a gas is formed. The gas decolorizes acidified potassium magnate 7. So this is a test for the sulfide ion, because sulfide ion decolorizes acidified potassium magnate. If this sulfide ion, the salt of the sulfide ion is SO3 minus 2, is formed with acid, it will produce SO2 gas. So SO2 gas will be oxidized by potassium magnate. So we may have SO3 minus 2. When dilute nitric acid and aqueous barium nitrate are added, no visible reaction occurs. This test is for the presence of sulfate ion. So sulfate ion is absent. What can be deduced about the ionity of X? A. X contains only aluminum sulfate, Al2SO4 whole thrice. Wrong, because it must contains Zn plus 2 and Ca plus 2 also. X contains only calcium sulfide, CaSO3. Again wrong, because it's already written that the ions present in the aqueous solution is of Al plus 3, Zn plus 2 and Ca plus 2. C. X must contain aluminum sulfide, Al2SO3 whole thrice, or zinc sulfide, ZnSO3. This might be correct, but again, I can't consider this statement as the final answer. I have to look for the last statement in order to confirm my answer. X must contain aluminum sulfide, Al2SO3 whole thrice, yes. Calcium sulfide, CaSO3, correct. Or zinc sulfide, ZnSO3. This is the correct statement, only correct statement here. So only choice D will be the right answer here. 4. Which set of changes to the conditions increases the volume of a gas? Pressure decreases. Yes, it will increase the volume of a gas. Temperature increases. Yes, this increases the volume of the gas. Next statement, pressure increases. No, this decreases the volume. Temperature decreases. No, this also decreases the volume. Pressure increases. Yes, it increases the volume. Sorry, decreases the volume. This is wrong. Temperature unchanged. Unchanged means there won't be any effect on the volume of a gas. So this is wrong. D, pressure unchanged. Wrong. If you have pressure unchanged, how can you have increase in the volume of a gas? Temperature decreases. This is correct. Only statement correct is A here. Number 5. Ethylamine gas, C2H5NH2 and hydrogen fluoride gas, HCl, react together to form a white solid, ethylamine hydrochloride. At which position in the tube would a ring of solid white ethylamine hydrochloride form? So we have C2H5NH2 and HCl. I am going to calculate the MR of both of these, so we can easily compare the movement of these gases along this tube. MR of C2H5NH2. We have 2 carbon atoms. AR of carbon is 12. So 2 multiplied by 12 plus we have 6 hydrogen atoms. Sorry, 7 hydrogen atoms. So 7 multiplied by 1 is the AR of hydrogen. 7 multiplied by 1 plus we have 1 nitrogen atom. So AR of nitrogen atom is 14. So we will multiply 1 by 14. So final answer will be 24 plus 7 plus 14 gives 24 plus 7 plus 14. 45. 45 is the MR of ethylamine. So I am writing 45 here. What about HCl? MR of HCl. MR of HCl. We have 1 hydrogen atom. AR of hydrogen is 1. So 1 multiplied by 1 plus we have 1 chlorine atom. AR of fluorine is 35.5. So here the final MR will be 36.5. So I am writing 36.5. So definitely HCl will travel faster as compared to ethylamine. So A must be the final answer in this case. Number 6, element X can be represented by the symbol X, 14 and 6. Small number indicates the proton number. This is the proton number. And this is the nucleon number. And if you look at the periodic table, 6 is the proton number of carbon. So this must be of carbon. Which statements about an atom of element X are correct? Number 1, it has 6 electrons. Yes, it must have 6 electrons. Proton number 6 means, and the particle does not carry any charge, so it must have 6 electrons. Number 2, it has 8 protons. This is wrong because proton number 6 it does not have 8 protons. 2 is wrong. 3, it is an isotope of carbon. Yes, it can be isotope of carbon. The reason is that nucleon number is different. Nucleon number of carbon is 12. But here it is 12. Here it is 14. Number 4, it is an isotope of nitrogen. Wrong, because the proton number of nitrogen is 7. So this can't be the correct statement. Only 1 and 3 is the right statement. So C will be the right answer. 7, 2 isotopes of chlorine are Cl35 and Cl37. Using these isotopes and C12 and H11, how many different relative molecular masses are possible for the compound with molecular formula C2H3Cl3? So we have 3 Cl3. What are the possibilities? 3 Cls. Possibilities. All 3 will be of Cl35. Possibility number 1. Possibility number 2. All 3 chlorine are of Cl37. Possibility number 3. 2 are of Cl35 and 1 of Cl37. And the last possibility 2 will be of chlorine 37 and chlorine 35. So there will be 4 possibility for this one. C will be the right answer for this one. 8. Which row is correct? A, elements, graphite, correct. Iron, correct. Compounds, methane, correct. Water, correct. Mixture, air. Copper, wrong. Choice B, elements, graphite, iron, correct. Compounds, sand and water. Sand is wrong. Sand is also a compound and water is also a compound. This is also correct. Mixtures, air and brass, both are correct. C, elements, iron, water, wrong. Compounds, methane, yes. Graphite, wrong. Mixtures, air, yes. Brass, yes. D, elements, water, wrong. Methane, wrong. Compounds, air, wrong. Graphite, wrong. Mixtures, iron, wrong. Brass, correct. So we have only one choice correct, and that will be B here. 9. Which statement about ionic compounds is correct? They are all solids at room temperature. This is correct statement because all the ionic compounds exist in the solid state at room temperature and pressure. B, they all conduct electricity at room temperature. They do not conduct electricity at room temperature. We have to dissolve them in water or melt them. They are all soluble in water. This is wrong because most of them are soluble, not all. If you want, I can give some example. You have insoluble sulfates like barium sulfate. It's an ionic compound. It's insoluble. All carbonates are insoluble except group 1 and ammonia. So not all the ionic compounds are soluble. They all have strong intermolecular force. This is also wrong because they have strong electrostatic force. So only choice A will be the right answer here. Question number 10. A molecule of tetrafluorosilane SiF4 is shown in the dot and cross diagram. Only the outer shell electrons are shown. Which statement is correct? A. Each molecule of SiF4 has exactly 16 pairs of electrons. This is wrong. The reason is that they didn't mention that whether they are talking about the valence electrons or innermost electrons. So we have to include all the electrons in both silicon and fluorine. And you can't have 16 pairs of electrons. B. And SiF4, both the silicon and fluorine have the same electronic configuration as neon. First of all, I have to look at the proton number of silicon and fluorine. Silicon, it's 14. Fluorine, it's 9. 14 and 9. Silicon has gained 4 electrons and each fluorine has gained 1 electron. So let's count the total number of electrons for each of these. So both of these are different. So you can't have same electronic configuration as neon. Not both. C. Molten SiF4 will conduct electricity. This is also wrong because this is not ionic compound. So it will not conduct electricity. D. SiF4 has a low melting point. This is the right statement. The reason is that both Si and F are non-metals. So it's a covalent molecule. Both are non-metals. So the compound is covalent. Number 11. The table describes two properties associated with metals. Which row shows a correct reason for the stated property? A. Property malleable. Reason: the layers of metal anions can slide over each other. This is wrong. B. Property is malleable. Reason is the layers of metal cations can slide over each other. This is the right statement. But let's read the other statements also. Property conduct electricity. Reason: metallic structures contain mobile anions. Wrong. It must have mobile electrons, not anions. The last one, conduct electricity, metallic structures contain mobile cations. This is again wrong. So only choice B will be the right answer here. 12. Aqueous silver nitrate, AgNO3, reacts with aqueous potassium chromate 6, K2CrO4 to give a yellow precipitate. What is the ionic equation for this reaction? This is an example of double displacement reaction. So products will be AgNO3 plus K2CrO4 AgCrO4 Ag whole 4 Ag2 plus CrO4 plus 2 KNO3. Now balance the equation. So we'll get this. We know that KNO3 is the soluble salt. So both K positive and NO3 ions will be cancelled out on the left hand side as well as on the right hand side. We are left with 2Ag positive. 2Ag positive. You have to write aqueous plus CrO4 2 minus. This will be the charge on the polyatomic ion aqueous, and the product will be solid, which is Ag2 CrO4 solid. So only choice C will be the right answer in this case. 13. What is the relative formula mass of anhydrous sodium carbonate? Write down the formula and calculate the MR, and that will be the formula mass of anhydrous sodium carbonate. The formula of sodium carbonate will be sodium is in group 1 and carbonates carry -2 charge. Sodium, the charge on sodium is +1. Ignoring the charges, we'll get this. These subscripts will be exchanged and we will get Na2CO3. So I'm going to calculate the MR of Na2CO3. We have 2 Na. So 2 will be multiplied by the AR of sodium. In this case, the AR of sodium is 23. So I will multiply it by 23 plus. We have 1 carbon atom. So 1 will be multiplied by the AR of carbon, and that is 12. 1 multiplied by 12 plus 3 atoms of oxygen. So 3 multiplied by AR of oxygen. Oxygen, it's 16. So we have 46 plus 12 plus 48. If you will add up these values, 46, 12, 48, 8, 9, 10, plus 6, 16, 6, 1 carried, 4, 8, 9, 10, 106. So C will be the right answer. 14, what contains the greatest mass of solute? So first of all, you have to calculate the moles of each. In A, 100 centimeter cube of 1 mole per dm cube sodium hydroxide. So for sodium hydroxide, 1000 centimeter cube. 1 dm cube means 1000 centimeter cube contains 1 mole. Therefore, 100 contains x mole. So it will become x is equal to 100 divided by 1000. 1 by 10. 0.1. 0.1 mole. So you have to multiply 0.1 mole with the MR of sodium hydroxide. MR of sodium hydroxide is NaOH. 23 plus 16 plus 1, we will get 40. 40 multiplied by 0.1, we will get 4 grams. So here we have 4 grams. B, 500 centimeter cube of 0.05 mole per dm cube sulfuric acid. So first of all, calculate the moles of sulfuric acid. 1 dm cube means 1000 centimeter cube. 1000 centimeter cube contains 0.05 moles. Therefore, 500 centimeter cube contains x moles. So you will get x is equal to 0.05 multiplied by 500 divided by 1000. This is 1 divided by 2. So 0.05 multiplied by 0.5. 0.025. 0.025 moles of sulfuric acid. MR of sulfuric acid. MR H2SO4. AR of hydrogen is 1. 2 multiplied by 1 is 2 plus sulfur 32 and oxygen 16 plus 32 plus 16, 4 multiplied by 16. So we will get 2 plus 32 plus 64 and 98 will be the answer. Multiply 98 by 0.025. 98, 2.45 grams. 2.45 grams for B. C, 1 dm cube of 0.1 mole per dm cube potassium hydroxide. So it must be 0.1 mole. So you have to multiply 0.1 by the MR of KOH. MR KOH. K 39. 39 plus oxygen is 16 plus 1 is for hydrogen. So 39 plus 16 plus 1. 5, 56. So 56 will be multiplied by 0.1. 56 multiplied by 0.1. 5.6 grams. So far, this is the highest value. Okay, D, 2 dm cube of 0.01 mole per dm cube hydrochloric acid. So it means 1 dm cube contains 0.01, 1 contains 0.01, so 2 contains X. So 2 will be multiplied by 0.01, you will get 0.02 moles of hydrochloric acid. MR of hydrochloric acid, MR, HCl, hydrogen is 1 plus 35.5 for chlorine. You get 36.5. 36.5 will be multiplied by 0.02. Point 0.73 grams. So only C will be the right answer in this case. 15. How many tons of aluminium oxide Al2O3 are required to produce 27 tons of aluminium? Let's write down the formula first. If you will break Al2O3, you will get Al plus O2. Let's balance the equation. We have 2 here, 4 Al and 3 O2. We are concerned with Al and Al2O3. The MR of Al2O3. Aluminium is 27. So we have 4 multiplied by 27. What we will get? 4 by 7, 28. 4 to the 8, 8, 9, 10, 108. So 108 grams or 108 tons. Al2O3 and we have aluminium. How many? 4 aluminium. Sorry, this is for aluminium. $108 tons is for aluminium. I am writing aluminium 108 tons. What about Al2O3? We have 2 Al2O3 na? So we have 108 plus 2, 3 is 6, 6 multiplied by 16 is the AR of oxygen and we'll get 96. Add 96 to this, we'll get 204. 204 tons from 108 tons. So X tons from 27 tons of aluminum. Do the cross, we'll get what? We'll get X is equal to 27 multiplied by 204 divided by 108 and 1 and 2. So 2 multiplied by 27, we will get 54. C will be the right answer. We'll do this again. 27 multiplied by 204. 27 multiplied by 204 divided by 108. 51. Sorry, 51 will be the right answer in this case. That's all for today. Thanks for watching. Press like and share my videos. Give comments for more videos. Subscribe to my channel and press the bell icon.